Hi everyone, let's start now. So in this lecture, we will study division operation in relational algebra. Okay. So in the relational algebra, all other operations we have already seen. We have seen the basic operations, all the basic operators like selection, projection, join operation. Join operation is not a basic operation, but we have seen the basic operations like selection, projection, union, difference, and cross product and renaming. So there are 6 basic operators, and then we have seen some derived operators like join operators, natural join, equijoin, and conditional join, also known as theta join. Okay. Now in this lecture, we will study division operation. Okay, this is a very interesting topic. This is a really interesting topic that we will see. So it's a beautiful and interesting topic, and we will study this in most beautiful manner. Okay, so you will definitely enjoy this class. Now let's start. So division operation in relational algebra. So before that, okay, let's see division operation perspective one. So this division operation we will study division operation in the relational algebra. So let's see the division operation perspective one, the core idea. Okay, what is the core idea? Why we call it division? What is the reason we call it division? From where this word division is coming? Okay, so if you understand this, then this operation also you will understand. So why we use this word division? From where the word division is coming? Okay, so that we need to study. So the core idea of division operation. So let's start. Okay, now before that, you tell me, do you understand the division operation in mathematical algebra? Like in your normal mathematics, do you understand the division operation? Okay, so tell me, what is this? Like, do you understand this division operation? That is my question. So, for example, if I ask you, what is eight? What is what is this value? Okay, 8 divided by 4. What is this? 8 divided by 4. That is basically 2. Why this is 2? What is the reason this is 2? What is the reason this is 2? What is the reason this is 2? Because you can notice. And one more thing. Okay, tell me what is 8 divided by 3? What is 8 divided by 3? Okay, only tell me the quotient. Only tell me the quotient. So this 8 divided by 3, that is also 2. Why both of them are 2? Why both of them are 2? Tell me. What is the reason both of them are 2? What is the reason? Only tell me quotient, because of course, okay, only tell me the quotient. Like in the C language, C language, this means the quotient, right? This will give you the quotient, correct? This will give you the quotient, correct? So now tell me why this is also true, why this is also true. The reason is very simple. Okay, can I understand like this, that okay, when you divide this 8 by 3, then the result is 2, because this is the largest integer, because this is the largest integer such that, okay, because this is the largest integer, because this is the largest integer such that, remember, this is the largest integer such that this multiplied by this is less than equal to 8, such that this multiplied by this is less than equal to 8. Okay, is this definition clear? This definition, okay, yes or no? So can I say this is also the largest integer? This is the largest integer such that this multiplied by this is less than equal to 8. Okay, correct? Yes or no? So are you getting my point what I'm saying? Okay, remember, if I have you have some numerator, and this is your denominator, denominator, the result will be q. When can you say result will be q? So can I say this q is what? This q is the largest integer. Can I say this q is the largest integer such that, can I say this q is the largest integer such that this qd is less than equal to n? This qd is less than equal to n. Agree or not? Okay, yes or no? This definition, tell me, this definition is clear for the division operation? Like very simple. Now you, okay, now use this definition and tell me, using this definition, you tell me what will be the answer for 19, okay, divided by 5. What will be the answer for this? Tell me what is the largest integer. Remember, this is also, remember, okay, this is also, you can notice, 5 multiplied by 3, or maybe I can say 5 multiplied by 2. This is also less than equal to this, but this is not, largest, yes or no? Correct? This is not largest to satisfy this property. This is not largest to satisfy this property. Yes or no? This is not largest to satisfy this property. So what is largest? Who will satisfy this property? Okay, what is largest? Like if this is your numerator, this is your denominator. So tell me, what is the largest q? What is the largest integer q? What is the largest integer q such that this property will be satisfied? Such that this property will be satisfied. Tell me, such that this property will be satisfied. What is such largest integer q? That will be 3. Correct? Yes or no? The largest integer 3, the largest integer which will satisfy this property, that is 3. So here I can say the answer will be 3. Correct? Okay. Is this clear? Very simple. So you can notice for integer a comma b, if you have two integer a comma b, then what is a divided by b? What is a divided by b? A divided by b. You can also write like this. You can also write like this. Okay. So this means a divided by b. So what is this a divided by b? This is basically the largest integer q such that q star b is less than equal to a. Yes or no? Correct? So remember, the answer will be largest integer q. The answer will be largest integer q. This will be your largest integer q such that qb will be less than equal to a. Okay, so if you have this thing, very simple, you have a divided by b. The result will be, remember, for this the result will be what? For this the result will be what? The result will be something. The result will be some integer. The result will be some integer such that it should be largest. Okay, such that the result will be q such that q is largest to satisfy the following property. Q is largest integer to satisfy the following property. To satisfy the following property. To satisfy the following property, and the following property is q multiplied by b is less than equal to a. To satisfy this property, this is the largest integer. Okay, this is the largest integer to satisfy this property. This is the answer. Okay, now did you understand this? So now did you understand this? What is division operation in the normal mathematics, in the general mathematics? Very simple. The same you have to do for the relation. The exactly same you have to do for the relation. The exactly same. Okay, remember, the exactly same you will do for the relation. So now if you have a relation R, now if you have a relation, let's assume R, and you have another relation S, now do the exactly same for this. Okay, so tell me what will be R divided by S? This result will be what? This result will be Q. This result will be Q such that Q is the largest. Remember, this is also relation. Yes or no? These are relation R comma S. So this is also a relation. Agree? The result also will be a relation. So this is a relation such that Q is the largest relation. Q is the largest relation. Q is the largest relation such that Q is the largest relation such that Q cross product S. Q cross product S. Now this is your cross product. Okay. In the relational algebra, your multiplication is similar to cross product. Yes or no? So, okay, remember Q is the largest relation. Q is the largest relation such that Q cross product S should be subset of R. Yes or no? Are exactly same. Exactly same definition. Exactly same definition. Exactly same definition. Yes or no? Tell me. This is what I'm saying. If you understood division in the normal mathematics, what is the division operation? If you understood that, then do the same for relation. That's it. This is your chapter. The chapter is over. Okay. Really, the chapter is over. Is this clear? Tell me. Do the exactly same here also. Do the exactly same here also. R divided by S. This will be Q. This will be a relation Q. Remember, R divided by S. This will be a relation Q such that Q will be the largest relation. Q will be the largest relation such that Q cross S, Q cross product S will be subset of R. Q cross product S will be subset of R. Is this clear to everyone? Tell me. So we need to do some practice, right? Yes or no? Okay. We need to do some practice. Definition we have seen. but we need to do some practice. Let's do that. Okay, so that's okay. Basically do the same for the relation. Do the same for the relation. If you have relation instances a comma b, if your relation instances you have a comma b, then a divided by b is the largest relation instance q, such that q cross b is subset of a. This is the definition. If anyone asks you what is the definition of division, this definition you can tell. This is the definition. This is the core idea. Okay, but we need to do some practice definitely. Okay, let's do some practice. So tell me here. Let's take this. So this is your R1. This is the dividend, and this is the relation R2. Okay, let's find out for this question. Let's find out what we need to find out. So you find out what is R1 divided by R2. This Q you have to find out. Okay, this is Q you have to find out. So tell me, first of all, very simple point I'm asking. What should happen? Are very okay, step by step you tell me. Step by step you will tell me. Please okay. Remember, if you have this relation R1, what is this relation R1? What are the attributes? The attributes are a comma b. You divide by relation R2. You divide by relation R2. Take your copy pen. Take your copy pen. Okay, this is your relation R2. The result will be Q. Agree? Agree or not? The result will be Q. What should happen? What should happen? Okay, this should happen, yes or no? That Q cross R2, this Q cross R2, this Q cross R2, this cross product should be subset of R1. This cross product must be subset of R1. So what can you say about the schema of Q? What can you say about the schema of Q? The schema of this should be same as this. Agree? So you can clearly see that schema here should be same as the schema here. Okay. So what can you say about the schema of Q? So what can you say about the schema of Q? Tell me, what can you say about the schema of Q? Just tell me the schema of Q. What should I cross product? Okay, here you have attribute B. Remember, here you have attribute B. What should I have here such that this cross product will have this schema? Such that this cross product will have this schema. So can I say the schema for Q? The schema for Q, can I say this will be AB? Can I say this will be AB? The schema for Q, can I say this will be AB? The schema for Q. If this is the schema for Q, then what will happen? If this is the schema for Q, then what will happen? Then this will become what? Then this will become A, B, B. So definitely this is wrong. So definitely this is wrong. Yes or no? Agree or not? Agree or not? This will become wrong. Yes or no? Tell me. So definitely this is not the schema. So what should be the schema? Very simple. Q cross R2 schema should be same as R1 schema. So Q schema must be same as A. Yes, correct. So from here I can say the Q schema, that will be A only. So in the Q, you will have only one attribute A. Okay. Now that is fine. That is fine. Now what we need to do? Now we need to do what? So now we need to do this. That what should happen? This Q cross R2 must be subset of R1. This Q cross R2 must be subset of R1. Agree? Okay. So this should be subset of R1. Q cross R2. This should be subset of R1. So tell me, this R1 divided by R2. This R1 divided by R2. This is equal to Q. And you can notice Q has B. So can I say, will this work? Okay, if I tell you this work, okay, is this the final answer? Is this the final answer? Like, is this your final answer? Is this your final answer? Tell me. Is this your final answer? You can clearly see this condition is satisfied. Yes. Yeah, okay. So before that, you tell me, like 1, 2, 3. Will this be your answer? This 1, 2, 3. Will this be your answer? Why this will not be your answer? Because now if you do this, remember this Q cross with R2. Then if you do this Q, if you do this cross with this cross with this, then what you will get? This cross with this, what you will get? Definitely that is not a subset of R1. Definitely that is not a subset of R1. Yes or no? Agree? Definitely that is not a subset of R1, because 1, 1 is fine. 1, 3 is not there. Here you don't have 1, 3. We don't have 1, 3. We don't have 1 3, right? This 1 3 we don't have. In this you have 1 3 also. In this you have 1 comma 3 also, but we don't have 1 3 here. In this we do not have 1 3. So can I say this answer is not correct? Yes or no? Definitely this answer is not correct. So definitely this is not correct. This is not a correct answer. This answer is definitely not correct. Agree? Okay. So now the next. So you can notice this answer is not correct. But what about this answer? R1. In the R1 you have 2 attributes. In the R2 you have 1 attribute. Okay. In Q you have 1 attribute. Can I say this answer will be correct? If I say only, okay, if I say this 2, is this answer correct? Is this answer correct? Is this answer correct? Here, tell me. Sorry. Okay, so that is A. That is A. Okay, that is A. That is A. That is A. So because the schema of Q will be A. The schema of Q will be A. So that is your A. That is A. So tell me, is this your answer? Is this the correct answer? Is this answer correct? So here you can clearly see this is satisfied. You can notice this is satisfied. R2 cross Q, this is subset of R1. This is satisfied or not? Tell me, this is satisfied or not? This is satisfied. This is satisfied. But I am saying this is also not the answer. But this is also not the answer. Why? Why this is not the answer? Because this is not largest. This is not largest. Because why this is not the answer? This is still not the answer. Remember, this will satisfy. Because if you do the cross product, if you do the cross product, you will get what you will get. If you do the cross product, or I can this order I can follow. I can follow this order, Q cross R2. I can follow this order, Q cross R2. I can follow this. So you can notice if you do the cross product, what you will get? You will get 2 1 2 3. You will get 2 1 2 3. Okay, if you do the cross product, you will get 2 1 2 3. So that definitely this is satisfied. But is this Q largest? Is this Q largest? Tell me. Is this Q largest possible? The answer is no. So this is also not correct answer. Okay, because this is not largest. Remember, this is the condition. Remember, this is the condition that this should happen and Q must be largest. And Q must be largest to satisfy this. Largest to satisfy this. Yes or no? This is the answer. So these two conditions, this also must be there and this also must be there. So is this largest? Definitely this is not largest. So tell me what you will do now in this situation. Now you can very simply see that R1 divided by R2. This is Q A. Now, okay, you can notice this is the largest. You can notice. Tell me what will be the largest? Largest means you can clearly see I cannot take 1. Agree? Because I want to satisfy this condition. I want to satisfy this condition. I want to satisfy this condition. So can I take 1? Just tell me one by one. Can I take 1? Okay, tell me, can I take 1? I cannot take 1, right? Okay, I cannot take 1. I cannot take 1 because if I take 1, then what will be the problem? If I take 1, what will be the problem? The problem will be here you will have 1 3. Here there is no 1 3. Yes or no? The problem will be here you will have 1 3 and here will be no 1 3. So this will be the problem. Correct? Okay, so you can notice. So 1 is definitely not there. Okay, what about 2? What about 2? Yes, 2. Okay, 2 you can put. 2 you can put because 2 1 is also there. 2 1 2 3. 2 1 2 3 both are there. So 2 1 2 3. You can put 2. Very good. Okay, largest I want to create. Can I put 3? 3 1 3 3. 3 1 3 3. 3 1 3 3. That is also fine. 3 1 3 3. That is also fine. Can I put something else? Can I put something else? Can I put 4? Can I put 4? No, because 4 1 is not there. Because 4 1 is not there. Can I put 5? Can I put 5? No, 5 1 is not there. Okay, 5 1 is not there. So finally I can say I cannot put anything else. I cannot put anything else. Yes or no? So now tell me the answer. Final answer will be what? So your final answer will be what here? So this is your remember your relation R1 is A comma B divided by relation R2 which is B. The final answer will be QA and you can notice this will be the largest. Okay, the answer will be 2 3. And you can notice why this is your answer. Why this is your answer? Because this is largest. Because this is the largest relation to satisfy. Because this is the largest relation to satisfy what we are satisfying. This is the largest relation to satisfy Q cross R2 is a subset of R1. Q cross R2 is a subset of R1. Q cross R2 is subset of R1. Is this clear to everyone? Please tell me. Please tell me, is this clear? Okay, so the same thing you have to do here also. The same thing. Did you understand? Did you truly understand this? So your answer will be this. Okay, clear? Is this clear to everyone? So your answer will be, because this is the largest. Because this Q is the largest relation to satisfy this. Because this is the largest relation to satisfy this property. Now, do you know why the name division is coming? Why we call it division operation? Because ultimately this is the same as division operation in the normal mathematics. In the normal mathematics, you have the division operation. The same thing is here. So now, okay, let's do some more questions. Let's do some more questions. Okay, so this is your answer. Okay, anyway, you already know this is your answer. Let's do some more questions. Let's do this question. A lot of practice we are going to do. Can you take your copy pen? Can you take your copy pen? Okay, so let's do this one by one. Okay, tell this. So first of all, very simple question I am asking. First of all, okay, step by step you go. Understand everything step by step. In this, you first of all, you tell me, I have this A. In this A, I have S comma P. S number, P number. In this B1, I have P. Okay, in this B1, I have P. So in this, I have P. So first of all, you tell me, your schema will be what? Your schema will be what? Just tell me. Because remember, this condition must satisfy. Remember, this condition must satisfy. This condition must satisfy. This Q must be the largest and Q largest and Q largest and Q largest. Okay, and Q largest. So what should be the schema for Q? Schema for Q will be S. Very good. Very good. Okay, schema for Q will be S. Yes or no? Very good. Now, so this schema we got. Okay, we found the schema. Step by step I am going. So we found the schema. So now, can you guarantee this is the schema? Because yes, of course, because Q cross B1, remember Q cross B1, this should be subset of A. Agree? Q cross B1, this B1 if you take here, this Q cross B1 should be subset of A, and this Q must be largest. So schema you got. Very good. Now what? Okay, now you have to satisfy this condition. Now you have to satisfy this condition. So this schema you got finally. I can say that here. Okay, so this is A. In this A you have S comma P. In this B you have P. Okay, the final result will be QS. But this should be largest such that this cross, remember this Q cross B1, this Q cross B1, this must be this Q cross B1, this must be subset of A. Remember this must be subset of A, and this would be largest. So tell me, first of all, can I put S1? Remember this is S, so only focus on this S. Only focus on this, because this is S. So only focus on this S. Okay, only you can have S. So just focus on S. Only focus on S, because you have the schema of Q is S. In this Q you can only have S number. You can only have S number. So focus on S. Can I have S1? Can I put S1? Yes, I can put S1. Why I can put S1? Why I can put S1? Because S1 P2 is already here. Yes or no? Array S1 P2 is already here. So this condition is satisfied. S1 P2 is already here. This condition is satisfied. Can I put S2 here? Can I put S2 here? S2 P2 is already here. So condition is satisfied. This condition is satisfied. Can I put S3 here? Can I put S3 here? S3 P2 is already here. So this condition is satisfied. This condition is satisfied. Can I put S4 here? S4 P2 is already here. So this condition is satisfied. Okay, so this condition is satisfied. Can I put something else here? Can I put something else here? Can I put S5 here? Can I put something else here? Like, okay, can I put something else? Something else can I put? For example, can I put S5 here? Can I put S5 here? This S5 I cannot put. Why? Tell me what is the reason? What is the reason I cannot put? Tell me. Tell me the reason I cannot put. Why I cannot put S5? Because S5 P2 is not here. Because S5 P2 is not here. If I put S5, then here you will have S5 P2 and there is no S5 P2 here. So this condition will be violated. This condition will be violated. So this S5 you cannot put. Is this clear? This condition will be violated. So your final answer, you tell me. Just tell me your final answer. What will you say your final answer? So remember, this is your final answer. So final answer. So final answer Q. Final answer Q, that will be, remember, that will be only attribute is S number. The attribute will be S number. Your final answer will be this. It will be S1, S2, S3, S4. Tell me, did you understand division? Okay, did you understand the division operation? Can you say right now, at this point, can you say you understood the division operation clearly? Yes or no? The lecture is over. Okay, the lecture is really over. The lecture was over by the definition. When we saw the definition, the lecture was over. So this lecture is over. Now we will do just practice and the complete analysis. Okay, tell me the answer for this. Tell me the answer for this one. Again, you can notice your relation A. You want A by B2. You want A divided by B2. In B2, you have P number. Okay, in B2, you have P number. And in A, what you have? In A, you have S number, P number. So your result should, what should be the schema for the result? What should be the schema for the result? Tell me. What must be the schema for the result? The schema for the result should be S number. Yes or no? Why? Tell me why? What is the reason? Understand everything clearly. Why? Because this condition should be satisfied. Because so that this condition should be satisfied. And Q must be largest. And Q must be largest. And Q must be largest. Okay, this condition should be satisfied. So, and Q must be largest. So definitely the schema for Q will be S number. This will be the schema. Now tell me the, okay, so you have A, S comma P divided by B2, which has P. So the answer will be S only. Okay, the largest you want the largest, so that this condition must be satisfied. QB2 must be subset of A. This condition should satisfy. And you want largest. So can I put S1 here? Just tell me this point. Can I put S1 here? If I put S1 here, then see. S1 P2 is already here. That is very good, no problem. S1 P4, because you will do the cross product of Q comma B2. You will do the cross product of Q comma B2. So S1 P4 is already here. So there is no problem. So S1 I can put. What about the next? So can I put S2? You can notice S2 P2. S2 P2 I have here. No problem. What about S2 P4? There is no S2 P4. So I cannot put S2. What about the next? What about S3? This S3 P2. I have here, no problem. But this S3 P4 we don't have. So I cannot put S3. What about S4? This S4 P2 I have. This S4 P4 I have. So both of them I have. So this S4 I can put. Can I put something else? Why I cannot put something else? Because if I put something else, if I put S5, S10, S11, S100, if I put something else, then this condition will not be satisfied. So if I put something else, this condition will be violated. So anyway, so finally your answer will be this. So your final answer will be what? So your answer will be this will be your answer. Okay. S number. Okay, S1 comma S4. So your answer will be this. Isn't it interesting? Okay. Now you have become the expert. Now let's quickly do. Okay, so tell me the answer for this also. You have the two attributes S comma P, and in this B3 you have one attribute only. In this B3 you have P number only. Okay, in this B3 you have one attribute only. So your result should have S attribute. Your result must have the attribute S. Okay, your result must, remember, your result can contain only S number. You can only contain S number. So focus on S number because your result can only contain S number. Remember, yes or no? Your result can only contain S number. So just focus on S number. Can I put S1? Remember, this condition must be satisfied. This condition must be satisfied. Yes or no? Definitely this condition must be satisfied. So tell me here, this S1, can I put S1 here? Remember, this condition must be satisfied and Q must be largest, and this Q largest, and this Q must be largest. So here, can I put S1? Yes, because S1 P1 I already have, no problem. Okay, so you can notice S1 P1 I already have, S1 P2 I already have, S1 P4 I already have. So this S1 I can put. So this S1 I can put. Can I put S2? Can I put S2? No, because S2 P4 is not there. S2 P4 is not there. Can I put S3? No, because S3 P4 is not there. Can I put S4? I cannot put S4 because S4 P1 is not there. See, S4 P1 is not there. S4 P1 is not there. So I cannot put this. So your final answer will be what? So for this question, your final answer will be Q. Okay, the attribute will be S number only. The attribute will be S number only, and your final answer will be S1. Yes or no? That's it. You have become expert. Yes or no? Now you have become expert. Now you can do any amount of practice you can do. So tell me quickly the answer. Quickly tell me the answer now. Okay. Now you have already become the expert. So tell me. So here again you can notice in the relation R there are two attributes A comma B, and in the relation S there is one attribute A. So your output should have what? Your output should have which attribute? So your output should have B attribute. Okay, your output should have B attribute. Okay, now in this situation, because now remember, will I write this? Okay, because remember, you already know this. Actually, they are commutative. We know cross product is commutative. This we have already seen in the last class. We know cross product is commutative. Okay, as long as data is concerned. As far as data is concerned, the schema will be different. As far as data concerned. So as far as data is concerned, remember, as far as data is concerned, okay, so this I can say that this cross product is commutative. This cross product is commutative as far as data is concerned. So definitely, so remember, this R cross S, this is same as, this is equivalent to this. Okay, in terms of data, in terms of data, in terms of data, in terms of data. Okay, now here what I'm saying. So remember here for the, okay, for the quick purpose, remember you can write, because ultimately what you want, R which has A comma B attributes. Okay, so what you can do, you can write it this, you can write in this manner. Okay, it will become easy for you. Yes or no? Yes or no? Now you can write in this manner. Now you can write in this manner, it will become easy for you. Okay, so now you can write this manner. So this property must be satisfied, and Q must be largest, and Q must be largest. Okay, this property must be satisfied and Q must be largest. So what should be Q? In Q you will have B. Okay, so remember, S cross Q, S cross Q, S cross Q. Remember, the B will come. So remember, these attributes will come. Remember, only these attributes will come in the result. In the final result, only these attributes will come. Can I put B1? Tell me, can I put B1 here? Tell me, can I put B1 here? This B1? This B1 can I put here? So do this, A1, B1. Do we have A1, B1? Array, check this, check this, check this. Do this, S cross Q. Okay, so do we have A1, B1? Yes, we have A1, B1. Okay, so can I put you have A1, B1? Do you have A2, 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 B1? A2, B1, yes, we have. What about A3, B1? What about A3, B1? Yes, we have. So B1 I can put. Agree? I can put B1. Definitely I can put B1. Okay, what about B2? What about B2? Can I put B2? Do we have A1, B2? Do we have A1, B2? Yes, we have. A1, B2 we have. Okay, do we have A2, B2? A2, B2? Let's check A2, B2, A2, B2, A2, B2 we don't have. So we cannot put this. A2, B2 we don't have. What about B3? What about B3? A1, B3 do we have? A1, B3 do we have? A1, B3. A1, B3 do we have? Let's check. A1, B3 we don't have. So B3 also you cannot put. So B3 also you cannot put. What about B4? What about B4? A1, B4 we have. A2, B4. A2, B4 we have. A3, B4 we have. So B4 I can put. Can I put something else? Can I put something else? So no, I cannot put. So this is clear to you. Remember, this is clear to you that definitely only these entries can come. Only these entries can come. Nothing else will come. Only these entries will come. Okay, only these entries can come. Only these entries can come. Outsiders cannot come. Yes or no? Only these entries can come. Outsiders cannot come. This is clear to you. Okay, so now you don't have to ask this question again and again. Yes or no? Now you don't have to ask this question again and again. This is very simple, that outsider cannot come. Only these entries can come. Only these entries can come. Yes, nepotism. So here is the nepotism. Okay, only these entries can come. Okay, only these entries, they can come. And name is also B. B for Bollywood. Okay, so much coincidence. Yes or no? So much coincidence. So you can notice. So only these entries can come. The outsider cannot come. So you don't have to ask this again and again. Can outsider come? Okay, it will not come. So your final answer is what? Tell me your final answer. So your final answer is Q. In Q you have attribute B, and there will be two. There will be, I can say, B1 and B4. There will be B1 and B4. That's it. This is your final answer. Okay, clear? So everything is clear. Now let's see another way. Perspective number 2. Perspective number 2. Let's see the perspective number 2. Now we will see the perspective number 2. But this idea is very, very nice. Yes or no? This idea is very nice. Again, you can notice this R is a relation and you want T. T has B. So the final answer should have schema A. Definitely. The final answer must have schema A. Okay, so that what you can have here, QA cross TB. Why I am writing like this? In the last I was writing like this. Here I am writing like Q cross T. Why? Okay, because of this, so that there is no confusion. Does it matter if I write like this, or does it matter if I write like this? Does it matter? Does it matter? This does not matter, because this is commutative. It does not matter. But then why I am writing like this? See, you can write like this also, you can write like this also, but why I am writing like this? So that I don't get confused. Yes or no? Yes or no? So that I don't get confused. Okay, for our convenience, we are writing like this. So this should be subset of R. Okay, and this should be largest. So this Q, what I can put here? Tell me. In this Q, what I can put here? Only the entries of A. Only these entries can come. Only these people can come. Only these people can come. Only these people can come. So tell me, can A1 come? Can A1 come? So you can notice A1. So A1, B1 is already here. A1, B4 is already here. So definitely A1 will come. Okay, now the perspective 2. Now let's change the perspective. Just give me a second. Just give me a second. Okay, you find the answer. You find the final answer. What that will be? You try to find the final answer. So here, what? Okay, this is the perspective number 2. This is the perspective number 2. Can you notice? Okay, instead of going, see, we are going in which direction? So far, we are going in which direction? So far, we are going like this, in this direction. Yes or no? Then we are going here. Agree or not? Agree or not? So far, we are going in this direction. We are going in this direction. Okay, can we go in the reverse direction? Can we go in this reverse direction? So far we are going in this direction. See, so far we are going in this direction. We are going. So far we have gone in this direction. Can we go in this direction? Yes, we can go. Yes, we can go. Very simple. See, notice that basically whatever you will put. Okay, just observe this point. This simple observation you make. Just simple observation you make. whatever I put here, what should happen? Whatever I put here, what should happen? It must be, okay, remember, it must be paired with this and this in here. Yes or no? Whatever I put here, whatever x I put here, this x must be from here. Yes, whatever I put here, this x must be from here. Whatever I put, this x must be from here. And this must pair with both of them. Yes or no? And this must pair with both of them. So whatever x I put here, this x must belong to A, and x pair with, okay, x must pair with what? X must pair with every B. X must pair with every B. Yes or no? X must pair with every entry of table T. Entry of T. Correct? Every entry of TB. X must pair with every entry of TB. So this x must belong to, yes or no? Is this clear to everyone? So this x must belong to here. X should come from here. X should come from here. And whatever x I put here, this should x b1 should be here. X b1 should be here. X b4 should be here. So this is the point. This is what I'm saying. So I am saying that x belongs to this, and x must pair with every entry of TB in R. Okay, every entry of TB in R. Okay, and in R, I can say, in R, x must pair with every entry of TB. Clear or not? Okay, so like in this direction also you can go. So what this x can be? This x can be A1, because A1 is pairing with B1, B4. You can notice A1 is pairing with B1, A1 is pairing with B4. Can I put A2 here? A2 is pairing with B1, and A2 is pairing with B4. So this also I can put, this also I can put. What about A3? What about A3? A3 is pairing with B1. A3 is with B1, and A3 is with B4 also. A3 is with B4 also. A3 is with B4 also. Okay, what about A4? What about what about A4? What about A4? A4 B1 is there. A4 B1 is there. And A4 B4, do we have? Do we have A4 B4? Do we have A4 B4? No, so the A4 B4 we don't have. Okay, this is your another perspective. So your final answer will be this. This will be your final answer. Yes or no? Is this clear? Tell me. This is your final answer. So two perspective we have seen. Crystal clear or not? We have seen two perspective. Either you can go in this direction, or you can go in this direction. Yes or no? Now you can go in this direction. If you want, you can go here. Okay, like this you can fly. Like this you can fly, or like this you can fly. You can fly in any direction. Okay, because now you have understood how to fly. Yes or no? This division operation is not a, I can say, you don't have to by heart what is division operation and why we call it division operation. Yes or no? Now you understood it. Okay, and when we understand the concept, then we can fly. Yes or no? That is the beauty of understanding the concepts. Okay, now one thing I want to tell you, what is that? Understanding the concept is different from knowing the concept. Yes or no? Like if you have already studied, if by chance from somewhere, if you have already studied this division operation, then definitely you can solve the questions. I agree. Okay, you can solve the questions. But now do you feel that now you are understanding the concept and previously you did not understand the concept? Yes or no? Now are you feeling this? The difference can you understand? Understanding the concept versus knowing the concept. So remember, in the Go classes, one thing is clear. What is that? Getting answer is not enough. Getting answer is not enough. Of course, we will get the answer, but getting answer is not enough. We should understand everything. Okay, we should understand every aspect, every idea. Complete analysis we should do. Complete analysis. Okay, we will not leave anything. We should do complete analysis. Okay, now let's see. Let's continue. So tell me here. Now let's see some more questions. So let's see this one. So tell me what will be. First of all, okay, one by one. Now you will tell me. Now you will tell me everything. You will tell me everything. So help me. So here, what I want R divided by S. This is what I want. I want R divided by S. I can also write it R divided by S. I can also write it R divided by S. Okay. So I want R divided by S. In R, what you have? In relation R, you have A, B, C, D. Yes or no? In relation R, you have A, you have B, you have C, you have D, you have E. These things you have. In S, what you have? In S, you have D, comma E. Tell me very simple point I want to ask. What should be the schema of Q? The output. What should be the schema of Q? Just tell me this point. What should be the schema of Q? Very simple. Very simple, very simple. Remember, this property must be satisfied. Remember, this property must be satisfied. Okay, remember, this property must be satisfied that this cross S. Okay, when you put this here, so this Q cross S, this Q cross S, this should be subset of R. Yes or no? And this S already has DE. This S already has DE. This S has DE. And this has ABCDE. This has ABCDE. So this should have ABC. So this should have ABC. Yes or no? Definitely I can say this must have ABC. These three attributes must be there. Yes or no? This is the first step. So we found the schema of Q. We found this. We found the schema of Q. Now, once you found the schema of Q, now can you proceed further? Now let's proceed further. Now we will go in both the directions. I will give you, okay, direction 1, method 1, method 2, perspective 1, perspective 2. Okay, perspective 1, perspective 2, direction 1, direction 2. So in the perspective 1, what we will do? We will go in the direction of we will go in this direction. We will go in this direction. Okay, we will go in this direction. So let's see. So for here, what I will do, very simple. R, in R you have A, B, C, D. Remember, in R you have A, B, C, D, E, and in S you have D, E. So your final answer will be what? Your final answer will be ABC. Your answer will be ABC. And so here Q, ABC, this you must have. You must have Q, ABC. This you must have. Okay, let's do perspective number 1. If you have already done the question, can you apply the perspective number 1? Let's understand everything. Yes or no? Why understand only single thing? Why understand only one method? Let's understand every method. Oh, red wale answers hai. Oh, that's a dumb thing. Okay, the red thing is the answer, right? Okay, that's something dumb. Anyway, so don't worry. Okay, let's see. Okay, let's find out. Let's find out. So here, tell me ABC. So, okay, remember the entries will come from here. Okay, these entries will come from here. These entries, they will come from where? So these entries, this entry will come from where? This entry will come from here. Yes or no? Only these people can come. Agree? Agree or not? Only these people you have to check. You only have to worry about these people. You only have to worry about these people. Only these people can come. Only these people can come. Okay, remember, only these people can come. Agree or not? So only these people can come. You only have to verify these people. You only have to check these people. So whatever I put here, only these people can come. No one else can come. No one else can come. Only these people will come. Only these people. Okay, this is the first point. Now the second point. So tell me, can this person come? Alpha A alpha. Okay, can this person come? Alpha A alpha. Can this person come? Alpha A alpha. Okay, it sounds like someone is calling someone. Okay, so tell me, alpha A alpha. So tell me, so alpha A alpha, can I put this? Remember your S. You can put side. Okay, you can put side on S. If you want, you can put side on S. You can put that is your A1 and that is your B1. So now you can notice. Tell me, do we have this in R? Do we have this in R? Alpha A alpha with A1. Alpha A alpha with A1. Yes, we have. Yes, we have. No problem. No problem. Alpha A alpha with B1. Alpha A alpha with B1. We don't have alpha A alpha. Alpha A alpha with B1. We don't have alpha A alpha with B1. We don't have. So this alpha A alpha will not be there. Perspective number 1. We are solving the perspective number 1. So definitely this is a not correct. Yes or no? Definitely this alpha A alpha will not be in the answer. Okay, let's take the another. Alpha A gamma. Okay, alpha A gamma. What about this one? What about this one? You can notice alpha A gamma A1. We have this. Alpha A gamma B1, alpha A gamma we have B1. Okay, this is also very good. So this will be there. This will be there. Yes, correct. This we will have in the answer. In the answer, I will put it. Okay, what about the next? Alpha A gamma is done. Alpha A, now next is beta A gamma. What about beta A gamma? What about this? Beta A gamma. So you can notice beta A gamma A1. Beta A gamma A1 I have. We have beta A gamma A1, no problem. Beta A gamma B1. Beta A gamma B1 we don't have. We don't have beta A gamma B1. So here we, okay, this will not be there in the final answer. Gamma A gamma, tell me. Okay, now again the same sound. The same sound has come. So tell me, gamma A gamma. What about that? Gamma A gamma. What about that? That will be there because remember, gamma A gamma A1 is there. Gamma A gamma A1 is there. Gamma A gamma B1 is there. Okay, gamma A gamma A1 is there. Gamma A gamma B1 is there. So I will put this in the final answer. I will put this in the final answer. Okay, what about the last? Gamma A beta. Gamma A beta. So tell me here, this gamma A beta, this with A1, we don't have. Gamma A beta A1 we don't have. So I will not put this in the answer because gamma A beta A1 we don't have here. So finally your answer will be what? So tell me what is the final answer? Your final answer will be very simple. So from the perspective number 1, your final answer will be alpha A gamma, gamma A gamma. Okay, your answer will be alpha A gamma and gamma A gamma. This will be your final answer. From perspective number 1 is done. Yes or no? Are perspective number 1 is done, correct? So this perspective number 1 is done. So very simple, isn't it? Very simple. Okay, let's see the perspective number 2. Let's see the perspective number 2. Now let's solve the same question with the perspective number 2. What is the perspective number 2? Perspective number 2 means go in this direction. Agree? Go in this direction. Go in this direction. Okay, so directly you check from here. Does it match with this? So this Q I want to find. I want to find Q, A, B, C. Okay, so one thing is very clear. What is clear? One thing is very clear. If something will come from, okay, here it will come. These things are clear. See, these things are very clear that if I put something here, this will come definitely from here. Agree? So this will definitely come from here. This thing is clear. So this will definitely come from here. This will definitely come from here. Okay, that is fine. What is the second point? If I put XYZ here, then what should happen? This XYZ, this should pair with every, yes or no? This XYZ, this should pair with every entry of S. This XYZ, this must pair with every entry of S. This must pair with every entry of S. In R. Okay, this must pair with every entry of S in R. In this relation R, okay, you must pair with every entry of, okay, this. So tell me, this alpha A alpha, does it pair with everyone here in this R? This alpha A alpha in this R, does it pair with everyone here? This alpha A alpha, is it pairing with this? Yes, it is pairing, but it is not pairing with this. Yes or no? It is pairing with A1. This alpha A alpha, it is pairing with A1, but it is not pairing with B1. So I can say this is definitely not correct. So here I can say that this is definitely not correct. So this alpha A alpha, you will not put. What about alpha A gamma? This is pairing with A1 also. And this is pairing with B1 also. So both of them it is pairing. So I can put alpha A gamma. What about beta A gamma? This beta A gamma is not pairing with B1. This beta A gamma, it is not pairing with this. So we will not put this. What about the next? This gamma A gamma, it is pairing with A1 also. It is pairing with B1 also. It is pairing with A1, B1, both of them. So gamma A gamma, it will also come. What about gamma A beta? This gamma A beta does not pair with A1. gamma a beta does not pair with a1, so we will not put. This is your perspective too. This is the answer. Okay, so both the perspective you understood, yes or no? Clear? Both of them you understood, yes or no? So this is your division operation. Isn't it simple? What about this question? Tell me, what about this question? In this question, okay, you find, in this question you find r1 divided by r2. Okay, remember your r1 has a comma b, and remember your r2 has b comma c. Find r1 divided by r2. Find r1 divided by r2. Invalid, right? Are invalid? Not possible. Very simple. Very simple. Okay, why it is invalid? Can anyone tell me? Anyone tell me why it is invalid? Why it is invalid? So this is invalid. This thing is invalid. This thing is invalid. Why it is invalid? Because you can never have such a cross product. Okay, so this is invalid. But what is the logic? What is the logic why this is invalid? So this is invalid, but what is the logic? The logic is very simple. The logic is very simple, that you can notice there is no schema. There is no schema Q, yes or no? I forget about relation. There is no schema Q such that there is no schema Q such that Q cross R2 can be subset of R1. Agree or not? Tell me, agree or not? There is no such schema. You don't even have a schema. Forget about the relation. Forget about the instance. Forget about the instance. You don't even have such schema. There is no schema such that you can have this. There is no schema. There is no schema such that you can have this. Agree or not? Yes or no? There is no schema. Because tell me what will be the, okay, whatever you do, this will contain C. There is no C here. Whatever you do, this will contain C. This will definitely contain C, whatever you do. But there is no C here. So there is no schema here. I can say there is no schema such that this will happen. So this is invalid. Is this clear? So this is invalid. So final point. So when can you divide? So what can you say about the attributes of R, S? Now you have understood the core idea. Now you have understood the core idea, yes or no? Now that you have understood the core idea of division operation, tell me what can you say if you want to define R by S? To define R by S, what can you say about the attributes? Very simple. Okay, very simple. If you want to define R by S, then what should happen? What should happen? You must have something Q such that this Q cross S is subset of R. So what should happen? Their combination must have the set of attributes as R. So this is very simple, that you must have this type of situation. You must have something like this, A, B, and here your B, then you will have A. Agree? Agree? So what I'm saying, I'm saying that if you want to define if you want to define R by S, if you want to define R by S, to define this, what should happen? What should happen? I can say the attributes of R must be proper superset of attributes of S. Clear? Must be proper superset. At least one attribute should be there, yes or no? At least one attribute should be there. Can you define this? For example, there should be proper superset. Like for example, this is my question. Like, can I define this? If I have R A comma B here, and if I have S A comma B here, can I define this? Can I define this? This is also undefined. This is also invalid. This is also invalid. Why this is invalid? Just think about it. Just think about it. Why this is invalid? Because can you have something? Can you have, okay, so this is also invalid. Why this is invalid? This is invalid because what will be Q? What attributes Q will have? Okay, what attributes Q will have? So Q, okay, what attributes will be there in the Q? So definitely this is also invalid. So what I can say that attributes of R1, attributes of R must be superset of attributes of S. Okay, who told you this? Who told you this must happen? The core idea told you, yes or no? The core idea told you. The core idea of the division. Agree or not? Core idea of the division. Agree? So this core idea is very nice, yes or no? You don't have to by heart anything. You don't have to by heart anything. You don't have to rote learn anything. Okay, everything you can understand from the core idea. This core idea is telling you everything. Okay, so you can notice. So this to define R divided by S, this attributes of R must be proper superset of attributes of S, or I can say attributes of S must be proper subset of attributes of R. Okay, if S is 5, what do you mean? Is it possible? Is it possible a relation does not have attribute? Is it possible? A relation does not have attribute. Is it possible? Do you have, okay, can you create such a relation? Can you create such a relation where you don't even have attribute? You don't even have attribute. This is not possible. Every relation must have at least one attribute. Every relation must have at least one attribute. It may be possible that there is no row. Yes or no? It is possible, right? Yes or no? It is possible that there is no row. But it is never possible that you don't have attribute. You must have at least one attribute in every relation. Whatever relation you take, you must have at least one attribute. Okay. It is possible that there is no row. It is possible. So when you say empty relation, it means there is no row. There is no tuple. Okay. Schema should be there. You must have at least one attribute in every relation. Now, the division operation perspective number 2 that we have already seen. Okay. Both are same. Both are same. If something is superset, both are same. If A is if B is subset of A, if B if A is superset of B, if B is proper subset of A, then I can say this both are same. Here you can say B is proper subset of A. Here you can say this is proper subset. Here you can say proper subset. Here you can say proper superset. Both are same. There is no difference between these two. Both are the same things. So basically you are saying that attributes of S must be a proper subset of attributes of R. Both are the same thing. Okay, is this clear? Both are the same. This and this, both are the same. There is no difference. Okay, let's move on. So the division operation, the perspective number 2. Mavith, just wait. Everything will happen. Q can never be equal to, yes, it can never be equal to R or S. Yes, that is fine. Yes or no? That's correct. If you have, for example, of course, the schema cannot be same. Forget about anything else. The schema also cannot be same. If you have something like this, for example, if you have A, B, C, D here, and in this S, let's assume you have B, D, then what will be the schema of R? What will be the schema of Q? What will be the schema of Q? That will be AC. So how can they be same? None of them are same. Yes or no? So definitely you can notice none of them are same. None of them can be same. None of R, S, Q can be same. They don't even have same schema. They don't even have, okay, none of them have same schema. None of them have same schema. Just apply the definition. Just apply the core idea. None of them don't even have same schema. Is this clear? Nikhil, just wait. Just wait. Okay, everything will come. Don't worry. Okay, just wait. Now let's see the next. The next division operation perspective number 2. That is the another and simpler definition. Now the definition that we will see, that definition is easy to apply. Okay. Now the definition that we will see, that is easy to apply. That will give you answer very quickly. Okay. You will get answer very quickly. Now this perspective number 2, this actually we have already seen. So from the core idea, you can find this perspective number 2. From the core idea, you can derive another simpler definition. Okay, let's see this example. In this example, I told you what core idea is doing. Tell me what the core idea is doing. The core idea is doing basically it is going in this direction. The core idea is going in this direction. Agree? In this direction, the core idea. Okay, so very simple that you have this relation S, P and divided by B2. In B2 you have P. So your result must be QS. Okay, in the core idea, what we are doing, tell me. In the core idea, Remember, this should happen. What should happen? This Q cross B2. This must be subset of A, and this should be largest. So either you can go in this direction. So this Q, okay, only what will come? Only this S can come. Only this S attribute, S name can come. Only S name can come. Only these people can come. Only these people can come. Remember, only these people can come. So only these people can come. So finally, I can say that, can you put S1? So you are going in this direction. You are putting S1, then S1 P2 is here, then S1 P2 is here. So you are going in this direction. S1 P2 is here. And you can notice S1 P4, S1 P4. So you are going in this direction. Agree? Agree or not? You are going in this direction. You are going in this direction, that S1 P4 and S1 P4 is also here. So in this direction you are going, but you can go in the other direction also. Okay, like this you are going. So S1 will be there. Okay, next you can notice S2. For the S2, P2 is not there. S2 P2 is there. S2 P4 is not there. So S2 P4 is not there. Okay, what about S3? This is also not there. What about S4? What about S4? So S4, yeah, S4 will be there. So you are going in this direction, or you can go in this direction. So S1 is also there. So the answer will be S1 comma S4. The another direction is this. Okay, you know that your answer will, okay, you know your final answer will contain what? Your final answer will contain S number. So very easy. Just check that this S number. Look at this S number S1. Is it paired with everything here? Tell me. This S1, is it paired with this? Is it paired with P1, P2, P4? Is it paired with P2, P4? Yes, this is paired with P2, P4. Yes or no? This S1 is paired with P2, P4, correct? This S1 is paired with P2, P4. So yes, this is correct. Yes, this is correct. So put S1 here. So put S1 here. Next. What about S2? What about S2? Can I say S2 is paired with here? Everything here? Can I say S2 is paired with everything here? S2 is paired with P2, but S2 is not paired with P4. So I can say S2 will not be here. So S2 will not be here. Okay, in this you will not put S2. What about S3? Again, S3 is also not paired. Yes or no? S3 is not paired with everything here. Agree or not? S3 is not paired with P4. S3 is not paired with P4. What about S4? What about S4? Is it paired? What about S4? Is it paired with everything here? Is it paired with everything here? Yes, this is paired with P2 and this is paired with P4. So you can put S4. So this direction is very easy. Yes or no? So this is your perspective number 2. This is the perspective number 2. This was the perspective number 1. So this is your, I can say, perspective 1. Perspective 1. This is perspective 2. Which is your favorite? This is perspective 2. So, okay. First one. Most of the people are saying first one. But this second one is easy. Okay, it will save you time. The first one will give you intuition. The second one will save time. Is this clear? Yes or no? Those people who are saying the first perspective is better. Why are you saying this? Because of intuition, maybe. Yes or no? Because you are getting the intuition. Because you are getting the intuition. Okay, and this perspective number 2, this is time saving. So I can say this perspective now. Okay, remember this perspective 1. This perspective 1 of division operation. This perspective 1 is the core idea, right? This is the core idea. Okay, so this gives intuition. This gives intuition. This gives intuition. And this perspective 2 will save time. Okay, perspective 2 of division, it will save you time. It will save time. It will save time, and it is better. Okay, many times it is better also. So it will save you time. Okay, so hence we got a simpler definition. Yes or no? So finally we got a very simple definition. We got a very simple definition. What simple definition we got? So finally we got this simple definition. This is the definition we got, that if you have this, if you want to find out this, that if you have, let's assume A, B and divided by S, where you have let's assume A or B, whatever. Okay, so the result will be what? The result will be QB. The result will be QB. You know this. Okay, so here I can say in this result you will have those values of b. In this you will have those values of b. I can say, remember here what you will have. Here you will have those values of b. I can say those values of b. Those values of, I can say those values of b you will take. Remember those values of this b, this b. So those values of b you will take. Those values of b which pair with, which pair with every, okay, which pair with every, which pair with every value of s, which pair with every value of sa, or I can say s, or I can simply say s, which pair with every value of sa, or I can say s, or I can simply say s. So which pair with every value of s in R. Okay, which pair with every value of s in R. Is this clear? So those values you will get, those values you will get, remember. So those values of b you will get, those values of b you will get, which pair with every value of s, which pair with every value of s in R. Is this clear to everyone? Tell me. Okay, so this is the idea, very simple idea. You understood everything now. So you can notice what is this a divided by b. This a divided by b, this is the set of all values. Okay, this is the set of all x values. Basically a has x comma y. Here you can notice basically what the question is saying. The question is saying that a has x comma y divided by b has y. Okay, then what you will have? So basically you will, okay, your final result will have x. So you will have all x values, okay, such that for every y value there is a tuple. Remember those x values such that for every y value in b there is a tuple in a. Okay, so this is very simple definition. So this is very simple. So this is what you can do. So remember, now you can revisit all the previous questions okay, using this. So now you can revisit all the previous examples of the perspective 1. Now you can revisit them and you can solve those questions using perspective number 2. So can you try them? Okay, yes or no, you can do that, correct? So for example, now let's see this one. For example, let's do this one. This b3. Okay, let me do with b3. So let me do with b3. Let's forget about anything else. Okay, let me do with the b3. So the remaining you can do. The remaining you can do. Let me do b3. Okay, let me do this b3. So what will happen here? So this is your b3. You can note this is the b3 and this is the a. So if you do a by b3, what will be your output? Your output will be qs number. Your output will be qs number. Okay, so s number will be in the output. This s number will be in the output. So this s1, does it pair with everything here? This s1, does it pair with everything here? Tell me. This s1, does it pair with everything here? Okay, is it pairing? Does it pairing with p1, p2, p4? Yes, it is pairing with p1, it is pairing with p2, it is pairing with p4. So this s1 will be in the output. Yes or no? This s1 will be definitely in the output. Okay, what about s2? S2 is pairing with P1, S2 is pairing with P2, but S2 P4 is not there. S2 P4 is not there. So S2 P4 is not there. S2 P4 is not there. So this will not be there. What about S3? S3 P4 is not there. What about S4? S4 P1 is not there. Okay, this is very simple. Correct or not? Yes or no? So this is also very simple. Like this you can do. So this is your another method. Okay. Actually, that is the problem. Ekta is saying that she is using this method, this perspective number 2. She is using from the beginning. Why it is happening? Because you have already studied this division operation from somewhere, and they told you this just this definition. Okay, maybe something like that. Okay, I don't know. So okay. Anyway, I can say that today you will definitely understand this division operation, everything about it. This is a very simple, very beautiful operation. Okay, so everything about this operation you can understand. Okay, now let's do. So this also you can check. Okay, tell me about this one. Here also the same thing is happening. Here also the same thing is happening. What is happening here? Here also the same thing. So you can notice in R1 you have a comma b in this R1, and in this R2 you have b. So your Q will have A. So your Q will have A. So okay, your Q will have A. Now let us see. Now let us see. Now let us see. This one is paired with one. Yes, this one is paired with one, but one is not paired with three. One is not paired with the three. Yes or no? This one is not paired with three. So this is not in the output. So this is not in the output. What about two? Two is paired with one. Two is paired with three. Two comma one is there. Two comma three is there. So this two will be in the output. So this two will be in the output. What about the next? What about the next? Tell me. So this 3 comma 1 is there. This 3 comma 3 is there. So this 3 will be in the output. So answer will be 2 comma 3. So this method is time saving. Agree or not? This method is really time saving. Okay. What is the answer for this? Tell me quickly. Here. From here, what will be the answer? Like, so let's see one by one. So forget about this T here for a moment. Forget about this. So let's see this. So here you can notice R has A comma B. In your relation R, you have A comma B. In relation S, you have A. So your final answer will have B. Your final answer will be B. So okay, remember your final answer will be B. Your final answer will be B. So just focus on B here. Just focus on B here. Okay. So only focus on B. Now here you can notice. So this B1. Okay, this B1 is paired with everyone here. Can I say this B1 is paired with A1? This B1 is paired with A2. This B1 is paired with A3. Okay, yes or no? So definitely this B1 will definitely will come. Correct? Because this B1 is paired with A1, A2, A3. Okay. Next, what about B2? What about B2? So this B1 is done. This B1 is done. We are done with the B1. So this B1 is done. Okay. What about B2? What about B2? B2 is paired with A1. B2 is paired with A3. B2 is paired with A3. But B2 is not paired with A2. So B2 will not be there. So this B2 will not be there. Definitely this B2 will not be there. Next B3. What about B3? B3 with A2 is there. B3 with A3 is there. So definitely this also will not be in the answer. What about B4? B4 with A1, B4 with A2, B4 with A3. So yes, it will be in the answer. So answer will be B1, B4. So this is also another very simple method. Okay, tell me the answer for this question. Now you can remove this. Now tell me the answer. Here you can notice. Here this R is A comma B and this T is B. So your final output will have A. So remember your answer will only contain A. Only these people can come. Only these people can come, right? Only these people can come. So definitely only these people will come. So you check A1. Okay, you check A1. Is it with B1, B4? This A1, is it with B1? This A1 is with B1 also. This A1 is with B4 also. So this A1 will be there. So this A1 will be there because it is paired with B1 also. It is related to B4 also. What about A2? A2 is with B1 also. A2 with B1 also. And A2 with B4 also. A2 with B4 also. So this A2 will also come. What about A3? A3 with B1, A3 with B1, A3 with B4. Do we have A3 with B4? Yes, A3 with B4. Yes, A3 with B4. So A3 will also come. What about A4? A4 with B1. What about A4? What about this A4? A4 with B1 is there. A4 with B4 is not there. So this will be your answer. Your answer will be A1, A2, A3. Okay. So like this you can do. What about this question? Here also you can apply the same perspective. We have already done this. This question we have already done. Correct? Okay. From this perspective, because you can notice this is not, I can say this is, you can notice this alpha A alpha. This is not paired with this. This alpha A alpha. This is not paired with this. So something like this. So this question we have already done. You can check it out. Okay. So like this. Now the general definition of division operation. The general definition, what is that? The general definition is like this. Remember the general definition. The most general definition of a division operation. This is very simple. So you have a relation R. In this relation R, you can have this type of attributes. Like this type of attributes you can have. You can have any number of attributes. In the relation S, you must have proper subset of these attributes. In the relation S, you must have proper subset of these attributes. For example, let's assume you have AC. In this situation, your output will be what? Your output will have BD. Your output will have BD. Okay. This is the general situation. So here what you will have, in this what you will have, here you will have those BD. Remember, here you will have those values BD. So here I can say x comma y. So I can say this x comma y, this x comma y, this belongs to BD. Correct? Yes or no? This belongs to BD. So this will belong to BD. This is your B, this is your D. So they will belong to BD. Okay, so they will belong to BD such that, okay, such that this xy, okay, basically those values of BD, basically I can say those values of BD. Remember, so finally I can say here what you will have, here you will have those values of BD, those values of BD. Remember, yes or no? Those values of BD combined, those values of BD, okay, uh, which pair with, tell me, which pair with every value of S, 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 okay, in R, which pair with every value of S in R. Okay, yes or no? Clear or not? So which pair with every value of S in R? In R, in this relation R, okay, so they must pair with every value of S in R. So very simple definition. So this is the simple definition, and if you want to generalize this, you can generalize like this. Okay, you can generalize like this: A1, A2, and so on. Some attributes you have here AN, and then let's assume you have B1, B2. Okay, so something like this: B1, B2, and something like this BM. So divided by S, which has B1, B2, something like this BM. Okay, this. So what your output will have? What your output will have? Your output will have A1, A2, AN, right? Correct? Your output will have A1, A2, AN, right? Yes or no? So your output will have these values. Okay, your output will have these tuples. So these values you will have, these values of A1, these values of, okay, let me call it A. Let me call it A, and let me call it B, and let me call it B. So basically this is A. Basically this is A. So those values of A you will get, okay, which pair with every value of S in R. Okay, so I can say what I can say. I can say those values of A, okay, which pair with every value of B, which pair with every value of S, which pair with every value of S, which pair with every value of S in R, which pair with every value of S in R. Okay, yes or no? Is this clear? Tell me, is this clear to everyone? Okay, the simple point. Okay, so this is the this is how you can check. So can you check it? Is this correct? Is this correct or not? Let's verify this. Is this correct or not? So here also the same thing. So first of all, you want R divided by S. This is what you want. If you want R divided by S, then what it means? Remember, you will have output will be Q. Your output will be Q. In this Q, what results? You will have DE. In the output, you want R divided by S. You want R divided by S. So you will have ABC. Okay, this is the same question. Oh, this is the same question, right? Yeah, so this is the same question, exactly same question. This question we have already done. Okay, so because we have done this question, so you can check it out. Anyway, your final answer will be this. So this will be your Q. Okay, and what about this one? Here invalid, yes or no? Here R1 divided by R2, invalid. So this is a invalid. And what about R2 divided by R1? And what about R2 divided by R1? This is also invalid. Okay, this is also invalid. So both are invalid. Both of them are invalid. Okay, so can you solve this question? This question can I give as a homework? Tell me. Can I give this question as a homework? Very simple. Okay, your homework number 1 for today. For today, this is the homework number 1. So this is the question. This is a 2-page question. You can check. These are the options. These are the options. Okay, and this is the question. You can read it and you can check it. Let's solve this question. Of course, we will give more priority to GATE question. So let's solve this. So this is your GATE exam question. Now consider the database relation. Consider the database relation schema CR. That is your CR, course registration. Course registration, student name, comma, course name. So this is your GATE 2017 question on the divisibility, on the division relation in relational algebra. So now tell me, what will be the answer? So these are the class representative. Sorry, course registration. This is the course registration. Now, what about the next? So an instance of this is given. This instance is given to you on your screen. This instance you can check. Okay, so you can check this instance. Now the question is asking this. A very simple question. The question is asking this. So tell me, first of all, what is T1? You tell me one by one. What is T1? Now we will solve this question, but before that, what is T1? Let's find out that. Okay, let's find out that. So what is T1? So what T1 is doing? Tell me. So here the question, what is T1? In T1, what you have? So this T1 is the name for this table. This T1 is the name for this table. Remember, the T1 is just a name for this table. For this table, we are giving the name T1. To this table, we are giving the name T1. Okay, to this table, we are giving the name T1. This name we are giving. And what we are doing? Basically, from the CR, we are selecting those tuples where student name is SA and those courses. So can you notice this T1 is what? This T1 is set of those courses which student SA has taken. Yes or no? This T1 is a set of those courses, which student, okay, which student course name, which student SA has taken. So course name. Okay. So ultimately I can say this is basically set of those courses, which student S1 has taken, which student SA has taken, which student SA has taken, this student SA. Okay, very simple. So you can notice from the CR, you select those tuples where student name is SA. So from the CR, so what you will do from the CR, you will select those tuples where student name is SA. So you will select those tuples. You can notice you will select those tuples where student name is SA. Those tuples you will select. Check SA is there or not. Check SA is there or not. There is no SA. So finally, this will be your T1. Okay. So this will be your T1. Your T1 will be CA, CB, CC. So finally, your CA, CB, CC. Okay. This is done. So T1 is done, right? Okay. Now the next, what is T2? Tell me the T2. What is T2? T2 is CR divided by T1. CR divided by T1. So what this means? So the T2, that is CR divided by T1. So this T2, this T2, basically this is nothing but from this table, this ultimately what this means, remember in CR what we have? In this CR you have students and courses. In CR you have students and courses. In CR you have this. Okay. And in T1 what you have? In T1 you have courses taken by SA. In T1 you have courses taken by SA. Okay, taken by SA, I can say. Courses taken by SA. Basically in this T1 you have courses taken by SA. Courses by SA. So those courses you have. So finally your this division, what you will get? If I do this division, then what you will get? You will get those students. Okay, your final output will be what? In the final output you will have students. In the final output you will have students. So you will get those students. Remember, you will get those students. So those students you will get who have taken all the courses which SA has taken. Yes or no? Yes or no? Who have taken all the courses which SA has taken. CA, CB, CC. So this type of students you will get in here. This type of students you will get here. This type of student you will get here. Is this clear? So your T2, what is your T2? I can say your T2 is basically what? I can say T2 is basically the set of students. This is the set of students who have taken courses, set of students who have taken all courses taken by SA, who have taken all courses, yes or no, who have taken all courses, who have taken all courses taken by SA, taken by SA. So they have taken all the courses which are taken by SA. This type of students you have in T2. Now tell me the answer. So those students who have taken CA, CBCC, those students who have taken CA, CBCC, those students. So who are those students who have taken CA, CBCC in the T2? In the T2 you will have those students. In the T2 you will have those students who have taken CA, CBCC. So SA will be there. Of course SA will be there because SA has taken CA, CBCC. SA has taken CA, CBCC. What about SB? SB will not be there. SB will not be there. He has not taken CA. SC. What about SC? CA, CBCC. CA, CBCC. So he will be there. He has taken all the courses taken by SA. What about SD? CA, CBCC. So this SD will be here. And what about SE? What about SE? SE, CA, CBCC. He has not taken CABCC, CA, CBCC. What about SF? CA, CBCC. So he has also taken. So the answer, okay, SF also will be there. So in the T2 you will have what? In the T2 you will have SA, SC, SD, SF. So these students you will have total 4 students will be there. So number of rows in T2, that will be what? Number of rows in T2, that will be 4. Okay, the answer will be 4 because there will be total 4 rows. Okay, very simple question. Tell me, the complete analysis, did you understand? Yes or no? Now let's see the next question. So tell me the answer for this question. For any relation R, comma S, what is R cross S divided by S? Think about it. What is this? R cross S divided by S. What about this one? For any relation R comma S, what is R cross S divided by S? Yes, this will be R. This will be exactly same as R. Okay, remember this is an important point. They can ask you this question directly. This question they can ask you directly. Very simple. How can you prove it? Tell me, how can you prove it? Are very simple. If you have R, in R, let's assume you have A. Okay, this A can be set of attributes. In R, you have A. In this A can be set of attributes. Remember, this A can be set of attributes. Okay, in S, let's assume you have B. This can be set of attributes. Okay, now what about R cross S? This R cross S will have A, B. This R cross S, this will have A, B. Now, now can you notice? Every value of A is paired with every value of B. Yes or no? Here, every value of A, if you have some value here, okay, every value of A is paired with every value of B in this. So in this, definitely what will happen, I can say, in this, definitely what will happen, in this, every value of A, I can say every value of A, or I can say RA, paired with every value of B, every value of S. Okay, every value of S. So in this, every value of A, remember every value of RA, I can say that every value is paired with every value of S. So now if I do this R cross S, in this you have AB. Now if I divide with S, which have B, then what you will get? You will get Q, which is A. Okay, you will get this. But here, this should be largest also. This should be largest. So this will be same as what? Actually, this will be same as RA, because every value of A is paired with every value of S. Yes or no? Because every value of A is paired with every value of S. Every value of A is paired with every value of S. So you will get RA. So this is very simple to prove. You can very easily prove it. Okay. Just give me a second. So this is the point. And what is the answer for this one? What is the answer for this one? So for this question, answer will be S. For this question, answer will be S. So can you notice? Can you notice this division is reverse of cross product? Okay, so can you notice this division is just reverse of cross product? So can you notice this division is just opposite of cross product? It's just, I can say, reverse mechanism of cross product. Is reverse, or I can say opposite of cross product. Is opposite of cross product. Like division is a reverse of multiplication. Okay, so similarly here, so I can say that division is basically just reverse, or I can say opposite of cross product. So okay, so this is the idea, because you can notice if you have some relation R, you have relation S, then this will do this R cross S, it will combine everyone. It will combine everyone. And now, if you divide by R, you will get S. And if you divide by S, you will get R. Okay. So if you want to separate them, you can use division. Is this clear? If you want to, okay, if you want to separate them, then you can do the division. Yes or no? Here you are combining them. And if you want to separate them, then you can do division. Agree? Is this clear? Tell me. So if you want to separate them, then you can do division. Very simple. That what I'm saying, that you have R, you have R, you have S. So this R cross S will combine them. Okay, this will combine. This R cross S will combine everything. It will combine everything. I can say it will combine everything. It will create the mesh. Okay, it will combine everything. Now to separate. Okay, now if you want to get the, I can say, if you want to separate R, then what you can do? If you want to separate R, then you can divide by S. Then you can divide by S. And if you want to separate S, then what you can do? If you want to separate S, then you can do divide by R. Then you can divide by R. So this is the answer. Clear or not? Very simple. What is the answer for this question? Tell me. What is the answer for this question? True or false? This statement is true or false? The statement on your screen. Is this true or false? R divided by S. If R divided by S is equal to Q, then it will happen. If R divided by S is equal to Q for any relation R comma S, okay, if R divided by S is Q, then Q cross S is subset of R. Yes, by the definition, by the core idea. Who is telling you this? Okay, who is telling you? The core idea is telling you. Yes or no? Okay, by the core idea. Okay, by the core idea. By the core idea of division. By the core idea of division. Very simple. Okay, what about this one? What is the answer for this question? For any relation, if Y is a relation, if Y is a relation, such that Y cross product S, is a subset of R, then can I say, is this correct? Is this true? Y is a relation such that Y cross S is a subset of R. Then can I say this? This statement is false. This statement is a false, because this should be largest. This should be largest. Yes or no? This should be largest. Now this is the next question. This is the largest relation such that this will happen. Now this is the question. This is the largest relation such that this will happen. Then this will happen. True. Now this is correct. Is this clear? You must have the largest thing. Being subset is not enough. You must, okay, yes or no? Sorry, so largest relation should be there. This Y should be the largest relation such that Y cross S is subset of R. Clear? Tell me. Yes or no? So all these points, crystal clear. Okay, now let's see the next. This is very important. This is the very important. Can you write division operation in terms of basic operators? This division operation, this is a very important. So division operation in terms of basic operations, and this is very easy. Let me tell you the idea. Actually, what division operation is doing, if you notice, what a division operation is basically doing, it is basically giving you who is paired with everyone. Yes or no? Like if I have this R A comma B, and if I have S B, then what this division operation is doing? Then the division operation as R going to S. This gives those A. This gives those A. Remember, this gives those A. So this gives you those A's. Okay, who are paired with everyone, who have taken every value of B. Yes or no? Who relate to every value of B. Agree or not? Who relate to, or I can say who pair with. Okay, or I can say who pair with every value of S. Every value of S. Agree? Yes or no? Who pair with? So this will give you, remember, this R divided by S, this R divided by S, this will basically give you those A's. It will give you who pair with every value of SB in R. Clear? Yes. So tell me, if I want those people who pair with everyone here, those people who pair with everyone here, so what I can do? I can do those people who pair with at least one minus those people who don't pair with everyone. Okay, we will continue this in the next lecture. Okay.